Hello everyone, I'm Ngo from the OCR research group at Samsung SDS Research Vietnam. Today, I will represent our research, which is an approach in Vietnamese handwritten OCR. About the problem, in the recent years, OCR has become a powerful tool to help companies save tens of thousands of working hours on processing documents. In this presentation, I will talk about how we help our customer, what are the current limitations in the OCR field, how we approach our problem, and what result we got, and what are the works in the future. So I will start with some use case and in some example how we succeed with helping our customer. In the past, employees had to receive hard copies of documents, classify them, and then scan the text information from the document and input it on Excel files before submitting to the company data archive. But now, as we have OCR processing, the employees only have to review and recorrect the Excel files if needed before submitting. All the classifying, scanning, extracting, and inputting data can be done by computer. At Samsung SDSR, we are helping our customers saving costs by using OCR and deep learning technique to shorten their document processing time. Now, we are successful our Vietnamese customer, such as there are hospital, there are insurance company, and some factory, and some customer in industrial. We have succeeded them by processing various kinds of their Vietnamese handwritten form and cutting costs for them. For example, this is a case from the financial sector. So as you can see on the screen, this is an invoice from a Vietnamese company. So they have various kind of information that can be extracted from text. As you can see from the screen, there are many boxes in the text, and we have to output every single information from the blue shaded box. For example, the information to extract can be the invoice ID, as you can see here, or it can be a buyer's name, it can be a seller name, customer ID, ID number, address, prices, or date and time, and etc. So there are various kind of form and various text information to extract from any forms. So scanning and inputting the text to Excel file by human can be very time consuming. And by aiding our customer shorten their processing time with OCR technique, we are helping them cutting costs by a huge number every year. However, we are still facing issues with accuracy and customer satisfaction with our text recognition model, which I will talk about in the next slides. So this is the limitation of the traditional OCR approach. As you know, in the past, OCR problems are only approached with computer vision and image manipulation technique. But now the research orientation have been changed. For Vietnamese handwritten text recognition, where the OCR visual model have to face many difficulties, including truncated, blurry, and noisy text, as well as bad handwriting, and also in Vietnamese language, there are many characters that look very similar but have slightly different semantic meaning. As you can see on the screen right now, we will have very bad image sample that will be blurry, or this could be really noisy with the low quality of the scanner. And some people handwriting is really bad, so it's really hard to understand. And it's also hard for algorithm. Also, the visual model do not have any knowledge about grammatical rules or frequently used word in Vietnam. And also, in Vietnamese language, there are many characters that look very similar but have largely different semantic meaning. I can show you the words in the slide after that. Visual model also do not have any knowledge on context, and it can output many output character sequence that do not have any meaning or really out of context. As a result, we are now trying to develop text recognition models with both vision and language feature knowledge, and we have achieved promising results in Vietnamese handwritten text recognition. So for our overall architecture, we borrow the idea and part the implementation from the ABNet paper, raised like human, autonomous, bidirectional, and iterative language modeling for synthetic recognition. This paper was published at the 2021 IEEE CVF Conference on Computer Vision and Pattern Recognition. In this paper, the author have good idea on how to ensemble vision and language knowledge together. As you can see on the slides, they use their predefined vision model and bidirectional language model, which use the backbone and position attention modules. So these two architect block we work separately first, as in the blocks, so, and they will output their own output for after the linear and softmax, and they will have their output fusion later. For example, in this in this image, when the was showing was fitted to the vision model, it will try to predict the word itself and output the SHDVING sequence. So the feature of that sequence will save it and will be used later. The sequence itself will be fitted to the language models, go through the layers of the language model, and will be outputted with another sequence. So that sequence, the two sequence and embedding will be, sequence and feature will be fused later and output another sequence which is SHOVING. So that have recorrected the word a little bit, and iteratively they can also fit the sequence showing here to the language model once again, and hopefully it will recorrect the word to showing. So that's the idea. In this case, we have borrowed the ideas and we have our own some implementation. In this paper, we use two models. In this approach, we use two models accepting different kinds of inputs separately trained on different tasks. The visual models is used to deal with the image to sequence problem, and the language model deal with the sequence to sequence problem, where it accepts a phone sequence as input and output a predicted sequence with correction based on its knowledge about the language. On the other hand, the two outputs and model will want to output the same sequence, the gradual sequence. So we can fuse the embedding output to create a new sequence and train another sequence to further learning the feature, because they want the same output, or we can say gradual. For OCR vision model, we use the SRN model from the paper toward accurate syntax recognition with semantic reasoning network also were published on CVPR conference. But this paper is different from AVNet that is were published in the 2020 version of the CVPR, so it's 1 year prior to the AVNet paper. This model architecture uses ResNet backbone followed by attention modules. The model established high accuracy on public syntax recognition benchmarks, such as IEEE T5K, ICDAR 15, and ICDAR 13. For the language models, we use a 4-layer depth transformer architecture for the language model. It comes from a very famous and groundbreaking paper, Attention is Own Unit, published in the 31st Conference on Neural Information Processing System, or also known as the NIPS 2017, by the team at Google. In this approach, we have a training procedure including 2 phases. In the first phase, visual models and language models were trained with different datasets on different tasks. The visual models were trained for the traditional OCR task, which inputs an image, output a sequence, and trained with cross-entropy loss. About the language model, it was trained on mass character prediction task, which input a word, which also known as a character sequence, from a text corpus with 1 mask character, and will predict the full sequence by unmasking the mask character. In the second phase, the 2 models will be jointly further trained and a hyper model, and in this case, it's the multi-layer perception, will be introduced to start 2 models from the first phase. To stack the vision and language model together, an embedding vector was taken from the last layer before the linear and somax layer of each model, and then the 2 embedding vector will be concatenated to form an input vector to the hypermodel. In the inferencing procedure, an input image can be predicted by either single forward or iteratively forward method. These 2 methods will be described now and will be demonstrated with the picture. In the single forward mode, the input image will be firstly passed through the visual model to produce an embedding vector and a predicted sequence. So we can see on the screen here, we have an input with the Vietnamese word chung, C-H-U, and G. So this image will be first fed to visual model. The visual model job is to firstly output a visual embedding, so that's a presentation of the visual feature. And secondly, which will also predict a visual sequence. I call this because that's the sequence output from the visual models. So I call this the visual sequence or sequence A, and in this case, it's a sequence C-H-U-N-N, that's tune. And then the sequence tune will be tokenized and passed to the language model. And from here, the language model will try to output a language embedding vector to present the features of the language. Then both the present of the language feature and the vision feature will be concatenated and both passed to the hypermodel to produce a final predicted sequence. So let's call it the output sequence or the sequence B. And in this case, it's the chung sequence, C-H-U and G. In the iteratively forward mode, sequence will ask the same as the previous sequence A or the tune sequence. So the output sequence B will replace the output sequence A to go through the language model once again. But now, because the input sequence of the language model has been changed, the input model will have another token, and it will produce another language embedding. So in this second time, the language embedding will be fused with the own visual embedding here. But since the language embedding has been changed, the input to the hypermodel will change. So it can predict another output here. And usually the output at the second time is better than the output at the first time, because the predicted sequence at the second time is better than predicted sequence at the first time, and it will produce a better language representation. Just like we have trained the predicted sequence B with the predicted sequence we change the sequence A with the sequence B. We can also change the sequence B with any sequence C, D, E, F, and etc. So on this iteratively forward mode, the model can iteratively reproduce the language embedding and the output sequence as many times as you wish. So for benchmarking our approach, we have prepared two datasets: a Vietnamese text corpus for the language models and a Vietnamese text images dataset for the vision model. The text corpus was gathered from various Vietnamese newspaper, letters, and the words gathered will be split and trimmed to single words. The corpus after this stage were really skewed with many noise samples, so we will discard many samples with less than 50 appearing in the corpus, so we can avoid training with misspell or noise or only use word. So that's which results us in a corpus with 50,000 words appearing from 50 to 5 million times. So the distribution is really still very skewed. To further equalize our words histogram, we linearly mapped the old histogram bean count range from 50 to 5 million to the range 50 to 5,000, which result in a training corpus with 50,000 words and 26 million samples. So for more elaboration here, the corpus size is 26 million, and the words are the unique word, and this is the appearance. The text image dataset contains 20,000 handwritten words imaged from our employees and around 180,000 words generated from our text generation algorithm. We also prepare a test dataset containing 1,300 handwritten words collected from another source with more than 400 unique writers to benchmark the simple OCR approach and our approach using hypermodel head-to-head. A test image contains a single cropped word, and the test image will be resized to the 32 by 128 size. So after our testing, we will have a table below. And as you can see from the table, the new approach drastically improved the recognition accuracy level from here to here. But about the compute burden, it's only increased for around 10%, with a really nice trade-off. Compared to the traditional approach, the new approach with NLP-aided OCR have improved the recognition accuracy by more than 7% absolutely and nearly 9% relatively. In this slide, we will show testing sample for comparison purpose. Please note that the red color indicates wrong prediction and the blue color indicates improvement. As you can see, and any sample here, there are red color character and blue color character. So from left to right, we can see the first column or the column here. The hypermodal approach had done a good job by spotting words that do not follow Vietnamese grammar rules and successfully correct them. Like in the Vietnamese, the U letter cannot follow the C letter. Only can follow the Q letter, and we have successfully corrected that. Or in our language, the C letter can be the last letter of a word, and that case was spotted on. Also, like the case here is the double N is not a valid using a Vietnamese character, so it was recorrected. Another use case is demonstrated in column 2, this column in the middle, where the model fusing both visual and language feature to choose the right prediction. In the first place, the both sequence Phạn and Phạm looks possible, but the hypermodel uses its language knowledge to decide that they choose the output Phạm, because Phạm is much more popular names in Vietnam, so the chance to have a right prediction is higher. Also, in the same thing happened in the second case, where the word Quang is in fact a valid word in Vietnam, but it really rarely used and it do not have much semantic meaning. So in this case, the language model feature have been fused with the vision feature to look at the image again and decide that the correct word is Khương, not Quang. So in the last column, we can see fail case where the first predicted sequence had too many errors, and thus the language models and the hypermodel cannot choose a possible output, like when they have 4 or 3 or they have all the character miss prediction. We also benchmark our approach end-to-end with fully written Vietnamese name to evaluate the usefulness of the solution in real scenario. We prepare a second test dataset with 400 handwritten Vietnamese full name from 2 to 4 words with more than 400 unique writers. In this case, the both algorithms will be run on each word, and then we will compare the correctness of the full name. Like with this case, there must be both correct to be counted full name correct. Or in this case, all the 4 words have been predicted correctly. So in this step, the new approach with NLP-aided OCR model even outperformed the OCR vision approach by a larger margin, with 87 compared to 77% recognition on accuracy. Each word in a full names will be split and inferenced independently. So our approach can improve the prediction on many words at the same time, or as you can see in the example in the right, they both have the second and the fourth word wrongly predicted, and they can be recorrected at the same time in only one single run. So in one time, as the word is independent, there can be many words recorrection at the same time. However, our current approach still has some limitation. As you can see from the demonstrated samples, our approach still cannot handle samples with too much error from the visual model output prediction, as if there lies in this case when there are 3 or 4 mispredicted characters in one single word, the language model cannot have at all. Another word we have to focus in the future is that right now, the language model can only tokenize character, so sentence and paragraph context could be ignored. Switching from character to word tokenization will largely increase the size and compute burden on the language model. So it's really a hard task to do, but we will have to try. Also, in the future, we want to reach our target at 95% recognition accuracy on Vietnamese handwritten text. So we will still have a lot of work to do. And thank you for listening. That's the end of my presentation.